Okay, in class, I showed you several demonstrations. I had a makeup mirror. And I showed you that when the object was far away from the mirror, that the image was inverted, as we saw in the last section, meaning upside down, and it was smaller. And I also showed you that I could project it onto a screen. I could do that because the lines were converging. And pretty much all those rules that we saw in the last section about converging pieces of light and where they pass established where the image would be. Well, that same process works all the way from anywhere in this picture to the left of the focal point. So anywhere from this point back, okay, from the focal point right here back, the image is kind of going to be the same and the same rules are followed. But let's see what happens as we start to move our object closer. Let's draw an object and let's put it right on top of the focal point. There it is, right on top of the focal point. Now let's go back and establish our same bouncing lines that we had before. Bouncing rays of light. Let's take, and we're going to use this guy right here, and he's going to come in like so. And when he comes in parallel to the principal axis, I said that he's going to bounce through the focal point like that. Now I'm looking for two lines to cross because I know from the last section where they cross, that's where my image is going to be. Okay, now I've got to take a second line. Geez, where should I take it from? I've already gone through the focal point. I can't, it's got to come from the same point. It's got to come from right on top. Well, if I take another one right from the top, I could go right to here because this is the spoke on the wheel and it is a normal, okay? And if I go right to this point, I know that the angle in equals the angle out when measured to the normal, and it's going to bounce out just like this. All right, well, looks as though they're not going to cross. Furthermore, I just want to emphasize how the light is bouncing. It's coming like that, each one. It's coming from here. There's my arrow. And each one is bouncing out like that. These are not going to cross. Do you remember from the plane mirror section that we did that I said that my arrows that I were going to use looked like this. And they had a butt and they had a nose. And I had to flip so that flip the line so that they were butt to butt in order to try and figure out where my image is going to be. Well, guess what? That also works here. I'm going to take one of these guys, okay, and I'm going to flip them. Let's see, let's flip them. I'm going to take them. And I want to flip them. Okay, there we go. I'm flipping them like this. He's right over, so he's right in line, but now he's going in the opposite direction. And I'll draw my arrow in so I know it is butt to butt. This guy's butt to that guy's butt. And this is my flipped That's my flipped arrow on that side. Okay, now I got to see where the other one's going to cross. So I'm going to do the same thing again. I'm going to flip it. Hopefully they'll cross on the other side of the mirror because as I said in class, you can flip them, and if they cross, the image will appear to be in back of the mirror like it was with the plane mirror. Remember the plane flat mirror? The image appeared to be in back. If you stand in the mirror in your bathroom, you appear to be on the other side of the wall looking at yourself. So I can flip the second one too. I'm going to try that. I'm going to try flipping it. Let's see. Here it is over here. It looks like this. Okay, and I'm going to try flipping this over. I'm going to try flipping it over to the other side. Here it goes. Over like so. So it's in a straight line. Uh-oh. Guess what? This line flipped. It's butt to butt. But they're not crossing. Here's my second one. There's my second image, but it's not crossing. My second line, rather, but it's not crossing. And if it doesn't cross, well, I must have no image. And sure enough, that's the fact, Jack. That's the fact, Jack. If the object is on the focus or the focal point of a parabolic mirror, the image vanishes. It's gone. Disappears. Okay? So if you don't understand what we just did, go back and review this. Let's try and change the colors a little bit on this highlight so we can see. Make sure we understand what we got here. Okay. All right, some technical difficulties, but you get the idea. All right, so there's one more scenario we've got to do with this parabolic mirror. Okay, let's put our image back up there. All right, let's use the same line. This time we're going to put it up close and see what happens. There it is. It's right there. Okay, and now we're going to see what happened. By the way, in the last image, the lines did not converge, therefore you could not project it. It was a virtual image, and I'll establish that a little better in this segment. All right, now let's bounce some light. I'm going to try and bounce it. Let's see. Let's see, here's our first light beam coming out. We're going to bounce that light. It's coming in like this. And we know if it comes in parallel, it's going to bounce through the focal point, like so. But even if you forgot that, you could have used the center and drawn a spoke to the point where it hits right here. I'll do that in the next section. I need two lines coming from the same point. I've already used the focal point, so I've got to make another line coming from the same point. So how about if I use the spoke of the wheel. In this case, the principal axis, which is normal, because I know the angle in is going to equal the angle out. It looks like it's about right to me. That looks like it's about right. Let's emphasize this a little bit with some color. Okay. Okay, here's the one coming like so. And I'm going to undo this in a second. It's coming to the principal axis, and it's going like that. All right, that sure is ugly. Let's put, sure is fun drawing with this thing, so I'm going to put some arrows on this. There's one going out. You already got the arrow on the other end, but you want to make sure, I want to make sure you can see it. Okay, and you can pick the butt of this guy and the butt of that guy. That's how the arrows are bouncing out. Now, first thing I want you to observe is that these are not sticking together, going together. They are diverging. These lines are diverging. They're going apart. Okay? Diverging. Going apart. Now, if they're going apart, then I cannot focus them. They are, in fact, can't be focused into a single point. Can't be projected onto a screen are, virtual, not real. Okay, I'll move this all the way down here and get it out of the way. I said what I had to say. You saw it. They are diverging. Let that one stay there. If they're diverging, well, maybe they pass somehow on the other side. So let's see if I flip them, if they end up being butt to butt. Butt to butt. Now let's try flipping them. Okay, there's one. Now I'm going to flip it all the way. Being flipped. Okay, and a straight line going back. Okay. The arrow looks like this. There's the butt of that arrow. He is butt to butt. Okay. Move him up a little bit, get him out of the way. Well, if I did it to one, I got to do it to the other because I'm a fair guy. Here's the second one. I'm going to flip him over so he's in a straight line. Okay, looks pretty straight to me. I'm going to draw the arrow. Because I flipped the whole thing, including the arrow. And here's the butt. Here's this guy's butt. They're butt to butt. Are they crossing? The answer is yes. They are crossing right here. Now I'm going to draw the image because my rule says where they cross, I draw the image. And that's what it's going to look like. Now I had this mirror in class. It's a makeup mirror. Do you remember, as I said before, when the object was way in back far away, when I showed you the flags in back of the room showing the mirror holding the mirror in front of the room, the flags were upside down in my room. The kites were upside down. When I moved it closer to a point on the focal point, the image kind of disappeared. And when I came closer, the image was upright, okay, which is what this is. Upright, meaning not inverted, and larger, magnified, larger. Okay. Well, this is pretty much all there is to convex mirrors. Go back and look at these. It's the same rules all the time. Remember, if you forget how it's going to bounce, this right here is the principal axis. It is a normal. You could call it a spoke of a wheel. You could call it a spoke if you wanted to. And the angle in right here, that angle in right there equals the angle out right there.